Hello guys, welcome once more to another video again in my channel. So in today's video, as displayed to you, we'll be looking at the GCE June 2019 question 4 of Roman 2, question 4 Roman 2 of paper 2. Okay, so this video is actually dedicated to advanced level students doing mathematics with mechanics. Okay guys, so please, I recommend that you like the video, subscribe to the channel, and don't forget to share with your friends. Okay, without wasting much of our time, let's look at the solution. So this is the question displayed to us, as you can see. So let's read the question and then we start looking for the solution. All right, so but before we begin, please, I appreciate everyone who is on my YouTube channel watching my videos. And please, if you find the videos helpful, don't forget to leave your comments in the comment section. Okay. All right guys, before we begin, look for a book and a pen so that you follow me step by step as I will be solving the solution. Okay guys, the comment section is open, like the criticism is open. Like you can see some mistakes that you can actually you can figure out some mistakes that I can be doing, or any other any other any other thing that you can notice that it is not actually, or maybe it's error or whatsoever. All right, so let's begin. Okay, now there's an important hint before we start diving into the solution. When the body or particle starts from rest, it implies that u equal to 0, where u is the initial velocity or the speed. Okay, so this is a general case when it comes to application of calculus, because like I'm saying like questions of this form. Okay, because what you have to take note of, like from this our own equation, that the particle starts from rest. Okay, these are the key point that helps you solve questions of this form. Okay, so in our case, our v is actually our own speed here is v, so this is like a general case. Okay, all right, so as we all know that acceleration is dv dt, but it is true that acceleration is dv dt. But before you start applying this procedure here, you have to first of all come back to your question, and then you figure it out whether we are looking for the speed as a when acceleration is given as a function of time, or we are looking for the speed when acceleration is given as a function of displacement. Okay, let's check. A particle starts from rest and moves in a straight line on a smooth horizontal surface. Its acceleration at time t seconds. So we have acceleration and then we have time. Okay, and then let's see. Its acceleration at time t seconds is k of 4v plus 1 meter per second squared, where k is a positive constant, and m and vms, like v meter per second, is the speed of the particle. So they're talking about acceleration, time, and speed. Given that v equals to e squared minus 1 divided by 4, when t is equals to 1, show that v is 1/4 is e power 2t minus 1. Okay, so from what we have just figured out, we can see that we are looking for speed when acceleration is given as a function of time. Okay, so since we know that acceleration is dv dt, it means that our acceleration given to us is actually k of 4v plus 1. Hence, our dv dt is equals to k of 4v plus 1. Why? Because dv dt is equal to the acceleration. But since the acceleration was given in the equation, means we have dv dt equals to k of 4v plus 1. Okay, so now you can clearly see that this is actually a differential equation. Okay, so for us to solve the differential equation, we have to separate these variables and then we integrate. Okay, so if I'm to separate these variables here, how am I going to do it? So first I'll cross multiply. If I cross multiply, I'll have dv equals to k of 4v plus 1 dt. Okay, now next, what you have to note is that like from here, right, I have the dv here, and here I have a term containing v in the side of the t. So it means I'm to remove this 4v plus 1, and then I send it the other side so that my dv and the term containing v will be in one side of the equation, and this other term containing t will be in the other side. Okay, so that is it. So what next? Now, for me to make for me to bring a 4v plus 1 on this other side, what are we going to do? We are actually going to divide all through by 4v plus 1, and then I divide this other side too by 4v plus 1. So at the end of the day, if I divide by 4v plus 1, I'm going to have 1 divided by 4v plus 1 times dv, or dv divided by 4v plus 1, okay, which is equals to k dt. Hope it is clear, because I'll be left with k here. If I divide this by 4v plus 1, the 4v plus 1 in the denominator, we actually cancel the 4v plus 1 in the numerator. Okay, so that is it. Now I can actually integrate both sides. So if I take the integral of both sides, I'm going to have the integral of 1 divided by 4v plus 1 dv equal to integral of k dt. Okay, now, so this is our these are our initial condition given to us. Okay, so here was actually supposed to be v, not u. Here was supposed to be v. Let me correct it. So here was supposed to be v. All right, so that is it. It was supposed to be v. Okay, so let's look at the left hand side of this our equation here. So the left hand side, so here, this is actually a standard result that you can just check directly from your formula booklet. I think it is there, or it's actually a standard result. If it's not there, it means it is not included. All right, so but I'm not going to use the standard result exactly. I'm going to integrate step by step. Okay, so this is like I'm going to use integration by substitution. Okay, so I will let a variable m to be equal to 4v plus 1. So if I differentiate m with respect to v, I'm going to have dm dv, which is equal to 4, because if I integrate a constant, or in general, if you integrate a constant, right, you have 0. So if I integrate 1, I'll have 0, and then if I integrate 4v, I'll have 4. At the end of the day, I'll have dm dv equals to 4. So I can actually look for my dv. So dv is just equal to 1/4 dm. Okay, hope it is clear. So yeah, I'm using integration by substitution. All right, so what next? From here, right, what is the purpose of me making dv the subject? Because yeah, if I substitute my m is actually 4v plus 1. I'll put 1 divided by m here, then times dv. You notice that m will be like a constant, okay, but which is not actually true. So I have to replace a term containing m, so that I have the integral of 1 divided by m dm. Okay, so that I can actually integrate that. All right, so at the end of the day, if I now replace this, if I know my m and then I know my dv, right, I can actually replace it here. So I have integral of 1 divided by m, because I know that m is equal to this. That is why m is included here, and then times dv. What is my dv? My dv is actually 1/4 dm times 1/4 dm, okay, which is equal to integral of k dt. All right, now you can actually notice that 1/4 here is actually a constant that I can move it outside. Okay, so at the end of the day, I'm going to have 1/4 times the integral of 1 divided by m of dm, or 1 divided by m dm. Okay, which is equal to the integral of k dt. Hope it is clear. Now from here, right, what is the integral of 1 divided by m? So the integral of 1 divided by m is actually ln m. Okay, and if you differentiate ln m, you have 1 divided by m. Okay, so that is it. Now since I already know my m, it means I'll have 1/4 times ln m. Okay, but my m is actually 4v plus 1. That is why I have 1/4 times ln of 4v plus 1. Okay, which is equal to kt. If I integrate k with respect to t, it means k will be like a constant. Okay, as we all know, even in the equation, where k is a positive constant, so it means I'm just going to remove k outside the integral sign. So if I remove k outside the integral sign, I'll be left with dt, and the integral of dt is actually t, and the t will be multiplied to this k. Hence all this, I'm going to have 1/4 ln of 4v plus 1 equal to kt plus the constant of integration c. All right, so from rest v equal to 0 when t equal to 0. Hence if I substitute v equal to 0 and t equal to 0, that is actually I'm actually looking for my constant of integration. Okay, so at the end of the day, my v equal to 0, I'll put 0 here, and my k equal to 0, I'll put my t equal to 0, I'll put 0 here. So these initial conditions are very important when dealing with this application of calculus. Okay, specifically equations of this form. All right, so what does it mean by saying a particle starts from rest according to this initial condition? Let me say you are the origin. Okay, and then you cover a displacement, let me say b, okay, from the origin. So it means when you were at the origin, right, your time was actually 0, your displacement, your v is actually 0, and even your displacement, I think, is 0. Okay, so therefore if you cover if you cover a particular displacement b meters from the origin, it means that your position changes with time. Hence your v, you cover a particular speed for you to arrive that point b, and your time will increasing. Okay, so that is it. All right, so now since we have substituted this, we will be left with 1/4 ln 1 equal to c. And if you take your calculator and input ln 1, you notice that ln 1 is just equal to 0. Okay, so that is it. So at the end of the day, our final equation now will be 1/4 ln of 4v plus 1 equal to kt, since the constant of integration is 0. Okay, so that is it. All right, now when t equal to 1, okay, when t equal to 1, why v equal to all this, right? Like saying when v equals to this, when t equal to 1, we have to show that v is equal to this. Okay, so it means that when t equal to 1, right, I'll put 1 here, so I'll be left with k. Okay, and then what next? It means we have to look for k, and for us to look for this constant k, it means we have to work with this other value. Since we have worked with the value of t when t equal to 1, right, it means we have two cases actually, if you can figure it out. So a particle starts from rest, it means that our v equals to 0 and our t is also equal to 0. Now when the speed is this and the time is this, they are asking us that we show that the speed now is this 1/4 e power 2t minus 1. I hope it is clear. All right, so from here, right, this is like another condition. Okay, so this is actually the initial condition given to us. This particle start from rest is not actually the initial condition. These are the initial conditions. Okay, so we have substituted when t equal to 1, we have this. So now if I substitute, because this one I'm to substitute them at the same time, so if I now substitute v, okay, I will have 1/4 ln 4v plus 1. So this is our v here, which is this. So 4v plus 1. Okay, now what do you notice? This 4 here we cancel with this other 4 here, so I'll be left now with ln e power 2 minus 1 then plus 1. Okay, so -1 plus 1 is actually 0. That is why I'll be left with 1/4 ln e power 2, which will be equal to k. Okay, so that is what we are going to have. And then for me to look for k, right, I will just cross multiply. So if I cross multiply, I'll have ln e power 2 equal to 4k. Okay, so now, and we know that ln e power 2 is just equal to 2. Okay, it means that I'll bring down this power here, so I'll have 2 times ln e, and according to the laws of logarithm, ln e is just equal to 1. Hence I'll be left with 2 equal to 4k. So if I divide all through by 4, I'll be left with, my k value will be half. Okay, so my k value will be half. So that is it. And then since we know our k value, which is half, I can come back now to this equation, here. I can come back here and then I substitute my value of k. Okay, so at the end of the day, I'm going to have 1/4 ln of 4v plus 1 equal to half t. Okay, and then here again, what next? From here, right, I can just cross multiply again, or I can multiply everything here by 4. So if I multiply by 4, the 4 here will cancel with this other 4 here, and then here I'll have 4 divided by 2, which is 2. So I'll be left with 2t. So at the end of the day, I'm going to have ln of 4v plus 1 equal to 2t. Now what next? For me to remove this ln here, right, I'm going to take e on both sides. So if I take e power ln of 4v plus 1 equal to e power 2t. Now from the laws of logarithm, right, if I have e power ln x, the answer is just x. Hence e power ln 4v plus 1 will be 4v plus 1. Okay, so at the end of the day, I'm going to have 4v plus 1 equals to e power 2t. And then if I make v the subject, like since I'm looking for v, I'll have 4v equals to e power 2t minus 1. Since the 1 is positive, if it crosses this equality sign, it will become negative. That is why I have this. Hence, if I divide all through by 4, I'm going to have that my v is equals to 1/4 e power 2t minus 1. And that is the required proof. So this is the proof up here. Hope it is clear. So please, thank you guys for watching the video. And as I said, the comment section is open for any mistake. Maybe I've made a mistake, I've made a mistake somewhere that you actually figure that out. Okay, so that is it. Please don't forget to subscribe to the channel so that you get notification for new videos. Okay, all right. See you guys in the next video.